In today's class, we're going to start linked lists. Now, a linked list is a data structure where elements are linked using pointers. Okay. Now, this linked list can also be implemented in an array, like we did with queue and stack. There are two important things in linked lists. The first thing is the data, and the next one is the pointer. Two things, data and pointers. Two important things in linked lists. Okay. Now, linked lists, for example, let me use use this as an example to illustrate linked lists, so everybody can just have an idea of linked lists. So if this is a new page that I opened. Now, do we have a page before this? After this? No. So we cannot go back, we cannot go forward. This is just a new page, it's just one page. So if I should draw this, then I will draw this as page 1, page 1. Now this page 1 is pointing to nothing, and nothing is pointing to it. That is just a page. Is that understood? Now, if I now go back to that page and click on, let's say, this, another page, I have opened another page. Do you know that this new page is not pointing to another page, but the previous page was pointing to this page? Now we have page 2. Is that understood? So if I can draw this, then I will redraw this as page 1 and page 2. So page 1 is pointing to page 2. Why? Page 2 is pointing to nothing. Is that understood? Yeah, page 1 is pointing to page 2, page 2 is pointing to nothing, and nothing is pointing to page 1. Is that understood? Now, if I go back to that page again, then because it's pointing to page 2, then I can easily move to page 2. Is that understood? Now, if I click on this, for example, this is another page, isn't it? So let me call it what? Page 3. So now I have page 1, page 2, and what? Page 3. So page 1, page 2, page 3. P1, P2, P3. Nothing is pointing to page 1. Why am I using -1? I will tell you. Page 1 is pointing to page 2, page 2 is pointing to page 3, and page 3 is pointing to nothing. Is that understood? So if you take a look at this, if you want to access page 2, you can, if you are in page 3, you want to go to page 1, you can never go without going through page 2. If you are in page 1, if you want to go to page 3, you cannot go without going through page 2. And if you look at this here, where are we? We are in page 3. If I want to go to page 1, there's no way I can jump to page 1, right? I have to go back to what? Page 2 before I get to page 1. Everything is linked to each other. Is that understood? If I want to go to page 3, I have to go to page 2 before I get to what? Page 3. Now in page 3, I can as well open another page that is called what? Page 4. Is that understood? So everything is linked to each other. Is that understood? Now, if we look at these pages, so let's say page 1 is saved at position 0. Page 2 is saved at position 1. Page 3 is saved as position 2. That means page 1 will point to what? To 1. While page 2 would point to 2. It points to that position. This is a page pointing to another position. Is that understood? Why there is no position pointing to what? To page 1. So since I'm starting from 0, then I can use -1 as what? As a non-valid index. Is that understood? So I call it a null. So, like I said, you can also have another page 4, right? Going into another page 4. So if page 4 is saved as position 3, so that means page 3 is pointing to what? To position 3 or index 3. Is that understood? And page 4 will point to what? Null. So null means that is the end of the list. Is that understood? Now, if you want to access a page, you must have a starting point and an end. So 2 pointers are needed to access this page, which is the start and end. The start is where you start from. The end is where you end at. If I want to access page 3, for example, page 3, I cannot start at page 1. If I start at page 1, that means page 0 does not even exist. Sorry, I cannot start at page 2. If I start at page 2, that means page 1 does not exist. Is that understood? So the instruction, the question, or the analysis you want to do will tell you where to start from and where to end at. So all these are called nodes. What do I call them? So this is a node, a node, a node. How many data does a node has? 2. What is the first thing? The data. What is the second one? The pointer. Is that understood? So a node has the data and what? And the pointer. Is that understood? So if I want to access page 2, the start will give me where to start from. The start will say start at 0. If I'm asked to start at 1, that means there is nothing at node 0. That is what it means. Is that understood? Now, if I'm starting at 0, then when I get to 0, I will look at where is page 1 pointing to. If I'm at page 0, I check the data at page 0. Is it what I need? Guys, what do I need to find? I need to find page 3, isn't it? Then I will start at where? 0. When I start at 0, then I will look at the data at 0 and compare it with page 3 if it is equal. Is that understood? Is it equal? No. If it is not equal, then I will look at the pointer at page 1 to ask where is it pointing to? Or where is it pointing at? Is that understood? Now, if I now look at page 1, where is it pointing at? Pointing at 1, isn't it? Then I'll go to index 1. Then I will now check data at 1 if it is equal to what? Page 3. Is it equal? No. Is that understood? Then, since it's not equal, then I will look at the pointer at what? At page 2. Where is it pointing at? Is that understood? Where is it pointing at? Index 2. Is that understood? Then I go to index 2. Then at index 2, then I will check data at 2 if it is equal to page 3. Is it equal? Now I've found my data. Is that understood? I've found my data. If I want to find a data, if I want to find page 6, I want to find page 6. Does page 6 exist? No. So let's find page 6, guys. Where are we starting from? 0. From 0. Now, I will now check data at 0 if it is equal to page 6. Is it equal? No. Then what do I do? Check the pointer. Where is it pointing at? At index 1. Is that understood? Then I will now check data at index 1 if it is equal to page 6. Is it equal? No. So then I check the pointer. Where is the pointer pointing at? Index 2. Then I check data at 2 if it is equal to page 3. Is it equal? Sorry, if it's equal to page 6, is it equal? If it is not equal, what do I do? Check the pointer. Where does it point at? Index 3. Then I check data at index 3 if it is equal to page 6. Is it equal? Then I check the pointer. Where does it point at? That is the end of the list. So page 6 does not exist. Is that understood? That is if you want to find a page. If you want to find a page. Now let's now try to insert a page. We want to insert a new page. We want what? Insert it to this list. So we want to insert a page 5. Are you all following me? Let us insert page 5. To insert page 5, now to insert page 5, I still need to start from where? From starts. Don't forget about this page I opened. If I want to open a new page, do I open it at page 1 or the next? The next. I don't open at page 1. Is that understood? So whatever I open now is now page what? Is now page 5. So it goes from here. It's linked from here. Maybe I click on this. It's linked. to this. Is that understood? So how do I check that? Then I look at the start. Where is the start? 0. If the start is 0, then I look at the pointer at what? At index 0. Is that understood? Where am I starting from? 0. This is 0, right? What is the pointer at index 0? 1. What does that imply? That means there is another page after. That is not the end, because I can only add a new page at the end. Is that understood? That means I will continue to add as long as the pointer is not equal to -1. Is that understood? I will continue to add as long as the pointer is not equal to what? -1. Is that understood? Now, I look at index 0. What is the value for the pointer? So, pointer of index 0 is equal to what? 1. What do I do? Then go to index 1. So, at index 0, the pointer is 1. Then I go to what? Index 1, because it's pointing to 1. Then at index 1, where is the pointer? 2. Then I go to what? Index 2. Is that understood? At index 2, what is the pointer? 3. Then I go to what? Index 3. At index 3, what is the pointer? It's -1. That means I will now add my value at the next index. Is that understood? I will do what? At the next index, which is now index what? 4. It is not index 4. No, you are wrong. Are you all following me? Why is it not index 4? You will add your value at index of end, where the end pointer is. The end is not -1. The end will point to the end, the last index. Is that understood? So, but in this illustration, the value for the end is not given. If the value for the end is 5, that means I will add that value to index 5. Then I will skip index 4. That is what it means. Don't forget, this is not an array. This is a memory location. That means I don't want to save it to this memory location. I want to save it to the next memory location. That is what it means. Is that understood? So that means I will add that value at what? At index end, the last index. Is that understood? This -1 is what? Is the last pointer. It means that is the last pointer, but that is not the last index. There is a difference between the index and what? Pointer. -1 means that is not pointing to anything. Is that understood? But where is the last index? If 5 is my last index, that means I will now save page 5. Are you all following me? Then I don't want to use 4. Let me use 5. Let me use I don't want to use index 4. Let me use index 5. That means I will save page 5 at what? At index 5, not index 4. So that means that initially page 4 is pointing to what? -1. I will now make it point to what? Point to 5. Is that understood? I will now make it point to 5. So that means instead of this to be -1, I will change the value from -1 to what? To 5. Is that understood? Now at index 5, I now have my value, isn't it? So what will index 5 point to now? -1. So it points to -1. Is that understood? So I've done 2 algorithms. How to read from a node and how to add to a node. I've done 2 algorithms now. So if you look at this explanation, like I said, it is not compulsory you must follow all the position. Is that understood? You can save the first one at position 100 and save the second one at position 2. That is the reason why this start is very important. Is that understood? I may decide to save this first page. Where did I save the first page to? Position 0. Let us save it to position 7. Is that understood? So where is my first page? Position 7. That means start will be equal to what? Start is equal to what? 7. Start will be equal to 7. Is that understood, everyone? So now it is unordered. Can you see? It is what? Unordered. Now, if I'm starting everyone, so let's try to add a new value. Now, what is the value for end now? Let's assume end is no longer 5. Do you know? Because I now have a value at position what? 5. Now, let me make end to be equal to 25. Let's add the value. Now, to add the value, where do we start from everyone? Position 7, because that is where we save the first item to. Now, index, we're starting at position 7. Where is that position 7 pointing to? What is the value for the pointer at position 7? 1. Is that understood? That means we go to index what? 1. Is that understood? That means we go to index 1 because it's pointing to 1. It's pointing at 1. That's like go to 1, then we'll go to 1. Now we are at 1. Is that understood? What is the pointer at 1? What is the pointer at 1? 2. That means it's telling us to go to where? Index 2. So we go to index 2. Now we are at index 2. Is that understood? What is the pointer at index 2? 3. It says go to index 3, isn't it? Now we are now at index 3. Are you all following me? What is the pointer at index 3? 5. It says what? Go to index what? 5. Now we are now at index 5. What is the pointer at index 5? That means index 5 is pointing to nothing. So where do I add my new data? I add it to the index of what? End. So my new data will be added to index what? 25. So it means that page 6 will now be added to what? To page 6 will now be added to what? To index 25. Is that understood? If it's added to index 25, what does that imply? It means that the previous pointer was -1, meaning that it's pointing to nothing, right? What should now be the previous pointer, everyone? It should now be 25. Why is it 25? To tell us that the previous value is now pointing to where? It's now pointing to where? 25, isn't it? So it means that this is no longer pointing to what? -1. It's now pointing to 25. Is that understood? And 25 which point to what? Nothing. So you will now come back here and you turn this to what? -1. So the question is now, what will be the value for end? Isn't it? That will be your next question. I will answer that very soon. Don't worry. So that means to implement linked list, it is either we use one 2D array or two 1D array. Is that understood? So with this, you cannot see that we need more than one array to implement linked list. Unlike you and what? Stack, where we use only one array, isn't it? So for a linked list, we need either two 1D array or one 2D array. We can also alternatively use object-oriented programming also to implement linked list without using array. Is that understood? Either we use two 1D array or one 2D array, or to use what? Object-oriented programming. Of course, yes. But although you may have some array just to keep your nodes, just one array to keep your nodes, not like two 1D array or one 2D array. You may just have one array to keep your nodes. That is all. Just to keep your nodes. So in correction, ordered or unordered have to do with serial, have to do with alphabetical or ascending or descending. That is ordered. So that was contrary to what I just said. Is that understood? But serially means you are going from one position to another. 0, 1, 2, 3, 4. That is serial. Random means you are just picking any position. We'll do more of that in paper 3. File organization, where you have serial, sequential, and random. Okay, good. Okay, welcome back again, everyone. Let's solve this problem. 2021 question 1. Let's start. It says that a class declaration can be used to declare a record. So anywhere you see a question on record, it is also a class declaration. Is that understood? So good. A list is an alternative to an array. This is not written in this year's question, so don't worry about that. Now, it says An unordered linked list uses a 1D array to store the data. So why is it using 1D array? Only one, because they are using what? Class to solve the problem. They are using object-oriented programming to solve this problem. If OOP is not used to solve this problem, it should have been either two 1D array or one 2D array. Is that understood? Okay, good. And another linked list uses a 1D array to store the data. So this is just used to store data about the linked list. Just store. Each item in the linked list is of record type node. Each item in the linked list is stored in the array. Is that understood? Each item of that array is of what? Record type node. Alternatively saying what? Object type node, isn't it? With a field what? Data. What is field? What did I say field is? Field is an attribute. Can you still remember? With field data and field what? Next node. So how many data do we have here? How many attributes do we have in the object? 2. Data and what? Next node. The current content of the linked list are, these are the current content of the linked list. This is the start pointer. What is value for a start pointer? 0. Empty list is what? 5. Empty list also means the end pointer. Understood? Or the list that is empty. The way it depends on how you interpret or define that to yourself. Now, these are the index where each data is saved rather. Data 1 is saved at what? Index 0. 5 is saved at 1. These are the index. And the next node are now the pointers. Is that understood? You can even see with a field data and a field what? Next node. So this is the index, this is the pointer, this is the data. So this is the current data in the linked list. The following is pseudocode for the record type node. Record type node, that is a class, isn't it? Type node. Declare data integer. What is that? The class. Declare next node integer, end type. Write program code to declare the record type node. Now we have to declare the record type node. Very simple. Let's do that now. So like I said, data and next node are the attributes. But are you supposed to pass a parameter? Yes. How do you know? Even if the question does not say. If you look at data, the value changes. Next node, the value changes. There is a variable. It's not a constant value. So you should know you are supposed to pass a parameter. Do you understand? And define your attributes as the what? Parameter value. Is that understood? So the parameter value. So writing the code, then we have class node. Okay, that should be class node. Then the def in it. Then self. Then what are the two values? Data and next node. Data and next node. Okay, then write self dot. Now the question is, are they private or what? Public. Self dot, I'm coming. Because we are not sure if they are private or public, although they are public. But let me use as private. Let's assume I am a student who is confused. Do you understand? I don't know if it's supposed to be private or what? Public. So let me make it as private. Do you understand? Let me make it a private. So on the long run, you will realize yourself that it is not supposed to be private. So if you are confused, make it private. When you are typing your code after this question, you will change it back to public by yourself. You will know it is not private. So let's continue. When we get to that point, we will determine that together. Understood? So let's make it private. So that should be dot data is equal to what? Data, isn't it? Then this should be what? Self dot next node. Self dot next node is equal to what? Next. Sorry, let me make it private. When the time comes, we'll see that it's supposed to be public and not private. If the question never mentioned anything about that, but we will know on the long run. Is that understood? Okay, good. So we are done with that question. We didn't add the comment, we didn't declare data and next node as integer. So data is declared as integer and next node is declared as what? Integer. Is that understood? Good. Okay, the next question. So we are just done with 2 marks. So it now says write program code for the main program. Now we are outside of what? Of the class. Now the main program. Okay, so that will be df main, isn't it? For the main program. Declare 1D array of type what? Node with the identifier linked list. Identifier means the name of the variable. Is that understood? So that means linked list is equal to, so this should be an array of type node, isn't it? You have to declare the array of type what? Node. And initialize it with data shown in the table on page 2. So not initialize with -1. Initialize with that data shown in that table. What should be the first value? The values in this linked list should be what? Should be nodes. Do you know? Should be of type node. That means you call the class node and you pass how many arguments? Do you pass? 2. What is the first one? Data. What is the second one? The node, the pointer, isn't it? So what is the data? 1. And that should be what? 1. Is that understood? That is the first value. Then the second value. What is the second value? What is the data for the second value? 5, 4. Is that understood, everyone? 5, then 4. Do you notice that? Do you understand this? So calling nodes the bracket is an object, isn't it? An object requires how many arguments? 2 arguments. Is that understood? Are you sure? Good. So node 5, 4. Then I complete it with the data. How many data do I have there? 9, isn't it? So these are just saving. I have not done anything. I am not arranging. I'm just saving the nodes. Each node to the what? To the array. Is that understood? So let's continue. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I can change that one by one. So I have 1, 1, 5, 4. 1, 1, 5, 4. Then 6, 7, 7 minus 1. 6, 7. And this will be what? 7 minus 1. And this is 2, 2, 0, 6, 0, 8. 2, 2. 2, 2, 0, 6, right? And this will be what? 0, 8, isn't it? And this will be 56, 3, 0, 9, 0 minus 1. 56, 3. What is the next one? 0, 9, 0 minus 1. 0, 9. And this should be what? 0 minus 1. So we just initialize the array. We did not print anything from the array, just put the nodes in the array. We haven't done any operation on linked list, you know. We haven't read from the linked list, we haven't write to the linked list. We are just putting it in an array. So the question now also says that what? It also says declare the what? Pointers. How many pointers do we have left? 2. The start pointer and what? Empty list. So that means start pointer is equal to what? 0. That means we are starting from 0, right? And empty list is equal to what? That means 5 is the end. Is that empty list? So we start at 0, we end at 5. So because of our time, I will continue this in the next class. But before I continue in the next class, if you look at the illustration, if you want to print out the whole array, let's forget about OOP now. Let's just talk about the array. You start from where? 0. You print data 1. Where is it pointing to? Index 1. So index 1 is what? 5. Where is index 1 now pointing to? Index 4. You now go to 4. The value is what? 2. Where is it pointing to? Index 2. That is 6. Where is it now pointing to? 7. The value is what? 56. Pointing to what? Index 3. Index 3 is now pointing to what? That is the end. Others are empty. Is that understood? We'll continue in the next class.